All right, let's go ahead and get started today. I'm going to be talking about telemetry. A lot of us kind of think of it as like kryptonite or something because it's not really thought of all that well. It's you always kind of wonder what's leaking out of your infrastructure. You always kind of wonder what information people are gathering about you. But it's honestly, it's how we know what to work on. So today, what I want to do is talk about kind of like the metrics that we're going to be gathering and how they are going to be benefiting you just as much or even more so than they'll be benefiting us. So I'll get started. Like Jillian said, I've been around for a little while, not quite as long as Nigel, and I don't have any fun fire alarm stories like that. But I have been around for quite a while. Like I talk to a lot of people, and I work with developers inside the company and outside the company, and spend a lot of time sort of like translating, getting people talking to each other. And one of the things that we've noticed, that has kind of held us back, not only inside but also outside the company, is just knowing how people are using our software, knowing what kind of parts of our modules people are using. So the idea of knowing what you need to focus on is something that has been sort of on the back of my mind most of the time that I've been here at Puppet, but recently I was given the opportunity to do something about that. So obviously, the reason why we need these metrics is that's how you know how your tools are going to be used, And not knowing all that information is really just kind of like flying blind, without a windshield or without your instruments, and just going on intuition. Where do you think the right direction to go is? And we often get kind of stuck into that because, especially with some of the new tools in the developer ecosystem today, it's really easy to get started building a module. It's really easy to get started making something kind of simple, making a sort of a bespoke Puppet module that manages one thing, manages it really well, does exactly what you want it to do. PDK new module, PDK new class, write some code. VS Code and the Puppet plugin make that real easy, and you even get automatic, like auto-generated testing, linting with PDK validate, PDK test unit, etc. So what's the problem here? Well, that comes when you start talking about maintaining something. If I'm building something just for me, I know what I need. It's pretty easy. But then pretty soon you're going to get a feature request from somebody like Tim who says, can we add Arch Linux support? And that, I mean, that's scope creep, but fine, sure. The problem is I don't know anything about Arch Linux, so I can't really write it. I can't really test it, and I'm sort of guessing to do it, right? What about adding other platforms? Or when somebody offers a PR? The thing is, every time you add functionality, even if it's trivial to accept that PR, maintaining it is not trivial. It's just more complexity. So to make effective use of our time, we really want to focus on the stuff that's going to give you like the most return, the most used code, the stuff that is going to benefit the most people. And another way of looking at it is really that if people aren't using something, then dedicating maintenance to it is just wasted effort. Especially if that thing, that class or whatnot, adds complications. Maybe it makes your testing more fragile, or maybe having more choices makes the user experience more complex. Now they have to configure a whole bunch of things instead of choosing some sane defaults, for example. I know that pretty well myself. I have an really old Drupal module. I think Dimitri might be one of the last remaining users of that, but it literally includes subclasses based on this really crazy complex case statement and string interpolation to decide which subclasses to include. And it was a lot more fragile than it needed to be, and it was a lot harder to read. So why do that? I mean, if people aren't using it, why do that? So I remember reading an article once that explained how your business should really sort of fire customers that cost you more to keep than they actually generate. It's something that they talk about in business school and whatnot. The idea of keeping focusing your effort on the most valuable customers. And likewise, maybe sometimes we just need to fire code that's not worth keeping. But then how do we know which code that we want to keep? How do we know which code we want to focus on? Well, with all due respect to Robert Frost here, as developers, we generally want to take the road most traveled. Because just like seeing the wear patterns in these roads here, knowing the usage pattern of our code is how we know what code to focus on or what code to get rid of. Now, SaaS applications, they're already used to getting these metrics because they've got observability and endpoint tracing built in. Like, for example, Twitter always knows what part of their platforms are used most consistently. But when you do on-prem software like Puppet modules, we have to gather those patterns in other ways. So first, I'm going to talk about an impact analysis tool that I'm working on. Now, this is basically means identifying the effects of changes you make to your code base. And obviously, that works best if you can do that before you break things. We've long been in a world where the way that we know when we break something, or the way that we know that somebody is using part of our code, is when we break it and they scream loudly. What if we could do that before we broke them? So this tool is called Rangefinder. I've been working on it for a little while, and it's pretty simple. You run it on a file. It figures out what that file creates, and it tells you what public modules on the Forge use it. In other words, in this example here, if we were to change the interface of how the concat fragment defined type works, all of these modules will be affected. And this is obviously quite truncated because there's a ton of modules that use that. It also comes as a GitHub app. So right now you can install it and you can have it run on every single pull request. And what that'll do is it'll look at the files that are changed, and then it'll identify what that file, what that changed file creates, and tell you which Forge modules use it. You can also see that those are links. So if you wanted to explore, see how people are using your code, see how people are using this thing that you're working on, you can just click through and get directly to the repository that these modules live in. The way it works is by static analysis of dependencies. Basically, it'll take the latest release of all modules on the Forge and just sort of dissect them. It'll turn them into, pull them all into parts and identify what every module uses. And it's static analysis, so it doesn't compile, it doesn't look at logic paths. It just identifies what resource types might be declared, what functions might run, what classes might be included. And so it can kind of sum up all the ways that a module uses components. And every single week it'll run and it'll generate that data and stuff it into a BigQuery database. Now, this data right now is available publicly in the public BigQuery database. I have some information about it at my blog, that's been for 2k.com, and there's also going to be links shared later on, so that as long as you have a Google Cloud account, you can already get to this data by yourself. So the query to generate that, the screenshot back here is basically the same query here. Is just select that information and identify what modules could be affected. But there's a major limitation here in that it right now only works on public Forge modules. So we can't identify how your code is used by profiles that people have running locally, or modules that people have created and have installed locally but have never published to the Forge. To truly know the spread and the impact of any of these breaking changes, we need production usage patterns from infrastructures that are actually using our modules. Or sorry, using components of our modules. But then that's an immediate red flag. Anytime a tool that I use phones home, I always wonder what it's gathering, like whether it's sneaking out information that I don't really feel comfortable sharing. So I run Little Snitch. I'm sure a lot of you do too, and I'll even use Wireshark just to see what kind of stuff is going out over the network, because this is a real big deal. And honestly, privacy and maintaining your trust was the first thing on my mind as I started building this. So a lot of people already are familiar with the idea of PII, personally identifiable information, but the same concept applies to business identifiable information. And it's really pretty obvious that if you share too much implementation information about how your infrastructure works, you're honestly just asking for security compromises. And for this reason, many companies don't even allow phone home metrics at all. More insidious is the idea of fingerprinting. And fingerprinting is identifying individuals or companies by properties or habits, like the kind of things you buy on Amazon or the kind of things that you look at, for example. And this will apply to infrastructures as well. So here's an example. If you saw a report from a site and said that it was in the Central European summer time zone, had the location set to Swiss French, and had thousands and thousands of nodes that were all classified with various HPC modules, you might guess that you were looking at CERN. And then you can use the rest of that record to kind of like as reconnaissance to identify what else they were running. So here's a live example of fingerprinting. I'm sure that many of you have heard of Panopticlick. Let me load this up in a new tab real quick. And what this will do is it'll use information about my browser. It'll look at various bits of information. It'll look at like the resolution of my screen, how much memory I have, how much, what plugins are installed. And it says that my browser has a unique fingerprint. Out of 300,000 browsers that have been tested in the last month or so, mine was absolutely unique. And so no matter how many cookies I turn off or disable, somebody could track me just by following all of these properties. And you'll see it's kind of obvious things. It's user agent, it's headers, it's browser plugins, it's time zone, the fonts that are installed. All of these things that are not considered to be sensitive information at all, if you combine them together, they are. So the hard requirements for this thing is that the act of sharing metrics data itself provides you with value. It's transparent about what kind of data is collected, why we're collecting it, what it's used for, and it doesn't gate any other benefits. So we don't say, well, you have to install this if you want to, have access to some other thing. We want you to install it because you get benefit out of it, and we want you to use it because you get benefits by using it. And I'll talk a little bit about some of the other benefits, why. And then all the data that's collected is going to be aggregated so that we can share it. We can safely share it publicly. So first, let's talk about how that data model works. Hopefully, this will help you help convince you that we're working really hard to meet those requirements. So that public data set doesn't have any access to individual records themselves. So that CERN example, you cannot get a full record that shows what modules are installed, what facts are run, how many, like what's in their Puppet files, et cetera, et cetera. All you can get is aggregated data. And it'll look pretty simple like this. It's pre-computed sums or counts and other data aggregations. Right now, this is the top 10 most used classes in the ecosystem. And because it's super limited, because we only have a handful of people like beta testers and internal customer zero sort of dog fooding clients. So there's not really a whole lot of data to start with, But in a couple of months, we'll have hopefully a lot of you checking in, and you'll be able to see what kind of modules people are using, what kind of classes people are using. Then once a week, that data that you're submitting is all aggregated using queries like this. We have a community metrics table, which is where all of our submitted reports go to. And then there's an aggregate query that selects all these things, combines them into a pre-computed metric, and then stuffs them into that public data set. Each query will generate its own table, and it's all pre-computed information. So we don't have a lot of queries yet, but we'll be adding to those as we learn more useful ways to dissect the data. And you'll actually even be able to help with that. You'll be able to suggest queries to generate this data. So the telemetry reports themselves aren't actually terribly sensitive. It's just a list of what public modules you have installed, what classes from those public modules you're using, whether you have private modules that have dependencies on public modules, whether you're running Ruby methods in your Puppet files, crazy things like that. But it very explicitly doesn't collect any data about any of your private modules, and it doesn't collect any data about like any of your facts or anything like that. But again, they are fingerprintable. So we store them only in that secured data set, and only a handful of people have access to that. Myself and then our BigQuery admin team, and really all they want to do is make sure that the Google Cloud services are running well. So any of our developers who actually want to use this collected metric data, they have to do it with those same aggregation queries, just like you would. So I'll talk about the framework of this telemetry tool and how the plugin design itself actually reinforces all this data consistency. Every time a plugin runs, it's self-validated against its schema and other things. The plugins are designed as hooks. So there's a handful of hooks that are pretty obvious, the description, and schema, and run. And then there's a few optional ones. So I'll go through and describe what all of these things do. The description is pretty obvious. It just tells you what this metric is and what it does. The schema is a BigQuery. It's a fragment of a BigQuery schema, and that is a JSON format with an array of row definitions that are all hashes. And that describes the data that each one of these metric plugins is allowed to return. Notice that I said the word allowed there. You have to declare, any of us writing metric plugins have to declare what data that we're going to gather in the plugin itself. And if we try to return any data that's not in that schema, then the whole thing fails. It blows up pretty spectacularly. Then you, as an end user, you can see that whole schema just by running the dev schema command, and you can see exactly what data is going to be collected and returned. The run hook generates that data. It's pretty straightforward. It just returns an array of rows. In this particular instance, we're only gathering one piece of data, so we return an array of 1, and it's not really all that terribly interesting. But we can return any data that the Puppet server node can generate. We can use Puppet DB queries, we can use Codebase, we can use Puppet libraries, etc. There are methods in there that will filter out private modules. So it'll actually check and make sure that you're only returning data about modules that exist on the Forge. And each week when it runs, it'll update that list. So it'll always know which modules are on the Forge. And this data that it returns must match that schema. So this schema here generates the same kind of schema that this run hook returns. And if it doesn't match, then it'll fail. So then example. Remember that I said that nobody has access to the actual data itself. All they have access to is aggregate values. So how do we generate, or how do we create the aggregate SQL queries that generate that data? We need to have some example representative data to work with. So that's what this does. This will return a kind of a randomized bit of data that looks pretty believable, and it's shaped like the real data set. And again, it also has to match a schema or the plugin fails. We use that to generate a randomized data set that's inside the public data set that I'm going to show you later on, that you can actually run SQL queries against, and then use that to develop what your aggregation query looks like. Then finally, you can preview what that report will look like. You just use the preview command. In this particular example, I'm providing it with just the single enable command, which will provide will select only a single metric. Otherwise, it'll run all of the plugins. So this runs that single plugin that we just looked at, and it'll tell you what it gathers. It'll tell you why it's gathered, and then it'll give you the data. Down at the bottom, it shows you a site ID. That's a cryptographic hash that just all it does is correlate the reports so that when we run our aggregation queries later on, you don't get counted twice. It cannot be reversed, but if you don't like that, if you want to regenerate it and use a different one, you can actually do that by just providing a seed value, and it'll calculate a different hash. So not only do we validate all of the hooks against the schema as it runs, we also use that same schema that is defined from the plugin schema hooks to build the data set itself. So even if you were able to return data that you didn't declare, the database wouldn't accept it. So now getting to the data is pretty straightforward. All you need is a Google Cloud account, and then you can explore these data sets. You'll see here that modules per environment, that's the aggregated form of the plugin that we've been looking at. There's several other ones that are listed up there: module usage count, class usage count, etc. These are all the aggregated data that are pre-computed. That same data set includes a lot of stuff. It includes all the Forge module metadata, all the static analysis of the Forge modules that we talked about earlier, information about GitHub repositories that look like Puppet modules. So any GitHub repositories that anybody's ever published on GitHub and made public that look like Puppet modules, we were using their public data set to gather information about it. And then all of this aggregated telemetry data, you can combine them all. So here's an example that'll get you a list of all modules that exist on the Forge that define custom native types. And what it does is it looks at the Forge to get a list of the modules, and then it also looks at Ruby files that exist in the actual repository itself, and then returns any that have the path of libpuppet type. So what else can we do with this? I mean, we don't know yet. The sky's wide open. Maybe we can incorporate some of that impact analysis into PDK validations. Or soon to be happening is the Forge will start to surface some of these metrics, and you'll get an idea of like the actual usage of modules you're looking at rather than just download count. Voxpopuli has a really cool tool that they use to kind of keep track of all of the modules that they manage. Sort of tells them which ones have PRs open, which ones are like out-of-date metadata or doesn't support the latest versions of different operating systems or whatnot. They can incorporate some of this usage data into that interface. Or maybe you'll write something. So, like any good community project, it doesn't actually go anywhere until I get you convinced. And it depends on at least some of you getting involved and helping out. So the things that I'm asking from you now are to install the module itself. You simply add Puppet Labs Drop Sunday to your Puppet file, install it on your Puppet server, and then just classify your main Puppet server with the Drop Sunday class. And that will get us a lot of data. It will be, it'll get usage information on the Forge a lot faster, and we'll all get a better ecosystem from it. But also, if you look at the source, and I'll post links in here shortly, if you look at the repositories, I'd love it if people looked at it and identified what sort of metrics they wanted to collect. So for example, like this doesn't even have to be just Puppet. It has to be related to the ecosystem. So for example, Reed made a plugin that looks at the impact of building a better control repo and Puppet file for better and more controllable R10K deploys. He's looking at doing it as data rather than an interpreted an interpreted Ruby DSL. So think like a YAML Puppet file or something. Or David Hollinger could look at the Vox Populi webhook and sort of identify how many people are using the different kinds of chat op integrations and maybe focus more or put more effort into some of them. And if you have yourself a Google Cloud account, it would be great if you actually built some tools that uses public data and publish them and help out the community with this. And with that, I'm going to go ahead and close up. I'm going to switch over. I'm going to put these into the chat, and I'll open up for questions now.
I think we have some questions coming through.
Yeah, I see that Raphael had one question. I'm grabbing the link to the repository right now. Yes, the engine that it uses to do the static analysis is a module that I built a little bit ago. It's called Itemize, and you can just install that and then run it as a Puppet face